Good day. Today we want to do June 2020 paper 1. And remember, when we are doing paper 1, you are not allowed to use a calculator. So whatever you're going to do here, you don't use a calculator. Paper 1, no calculator or logbooks. Then paper 2, that's when you can use the calculator. We are going to start from question 1, and I don't know how far are we going to get. Then the first one, it says, express 208.9 in standard form. When you're expressing a number in standard form, we know that the number must be less than 10. We need to write this number to be less than 10. So I'm going to say it's going to be 208.9. Then I want to see where am I going to put comma for this number to be less than 10, but greater than 1. It means the comma is going to be here, but multiply by 10 to the power of, then I check the comma you've moved how many places. It have moved to 1, 2. So multiply by 10 to the power of 2, because the comma have moved 2 places. So that's how you will express that number in standard form. Then the second one, okay, we need to see the question. Then the second one, it says express 208.9 to 3 significant figure. When you are expressing a number into 3 significant figure, you need to count how many numbers do we have. You must express it until to the third number, because in this case there are no leading zeros. So we start counting from, we have got 1, 2, 3. So we need to stop there. But 9 is bigger than 5, so it means I'm going to add 1. So it's going to be 209. It's going to be 209 when I express this number into 3 significant figure. Then the next one, correct to the nearest 100. To the nearest 100, we know this is units, this is tenths, and this is hundreds. So we need to express this to the nearest 100. So this number, we have got 0 next to 100, the 100th number. So it means it's going to be 200 because you don't add. So the answer is 200 if you express this number correct to 100. Then number 2, we move on to number 2. Number 2A, it says, evaluate minus 10. We are given minus 10 to the power of 0. And from the laws, we know that any number raised to the power of 0, it gives you 1. But in this case, you can see the minus is not inside the bracket. So what are we raising to the power of 0? We are raising only 10 to the power of 0. Minus 1 is not going to be affected by the power. If it was like this, to the power of 0, then the answer was going to be 1. But in this case, because the minus is not being raised to the power of 0, so this answer is minus 1. And I know most of you were going to write 1. There is the difference between the two. Bracket minus 10 to the power of 0 is equals to 1, because the minus is also being raised to the power of 0. But in this case, you bring down the minus and you raise 10 to the power of 0, which gives you 1. Then 2B, you are given 4/9 raised to the power of 3/2, which is going to be the square root of 4/9 to the power of 3, which is equals to, I'm going to start by removing the square root. What is the square root of 4/9? The square root of 4/9 is 2/3, but I also need to square that 3. And what is 2 to the power of 3? 2 to the power of 3 is 8. And what is 3 to the power of 3? 3 to the power of 3 is 20, 27. So that is what? That is your answer. This one was easy. Then we go to number 3. There is number 3 for you. You are given a Venn diagram. In the Venn diagram, we have got set A, B, and C. And you are given the elements that are in A, and you are given the elements that are in B, and the elements that are in C. Now, we know they are intersection. 9 is the intersection between, so the numbers that intersect at A and B, it's 9 and 1. The intersection of B and C is 1 and 7. And the intersection of A and C is 1 and 4. And the intersection of all the 3, it's only 1. 3 is found in all the what? The 3 sets. Now in this one, you are required, the Venn diagram shows the sets A, B, C with their respective elements. List all the elements of A intersection B. The numbers that are in A intersection B are those two numbers, A intersection B. We want the numbers that are found in A and also found in B. So the elements that are in A intersection B is 1 and 9. Then we go to the next one. List the elements that are in A union B complement. A union B complement. And before I go into this one, I need to find the numbers that are in A union B complement. The numbers that are in A union B complement. The numbers that are in A union B complement, it means the numbers that are not found in A and or that are also not found, that you don't get in what? In B. So those numbers are this one. The one that I have shaded, the elements that you don't find. So it's 11 and 13. But we want the numbers that are not in A or B complement, which is this one, intersection C. So it's that region also. The numbers that are in A union B complement is this one. But at the same time, they must be in C. So it's 11 and 13. And 30. Then the last one, it's find N. I think that N was a mistake. It was not supposed to be like a power. It's N bracket A union C. The number of elements that are in A union B. That are in A union B. A union B, I'm going to use this one. The elements that are in A union B is this one. But in this case, they just want you to write down the number of elements. So we go and count. They are 1, 2, 3, 4, 5, 6, 7. It's 7 of them. It's 7, the number of elements that are in A union C. They want A union C. I did A union B. Let me go and they want A union C. Let me erase this. We want A I did A intersection A union B. They want A union what? A union C, which is going to be this one. A union C. A union C, which is A union, this one that I've shaded now. Let's count there how many numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's still 7 numbers. A union C, it's still 7 numbers. So A union C, it's 7. The number of elements that are in A union C. Then we go to 4A. 4A, you are required to solve the following inequality. You are required to solve the following inequality. The way you solve inequality is the same way you solve what? Equations. You take minus y minus 3y minus y minus 3y, because if that 3 goes to that side, it's going to be negative, and this 2 goes to that side, it's going to be negative again. Minus 10 minus 2, which is equals to what is minus 1 minus 3, which is equals to minus 4. Is less than minus 12. Then you divide by minus 4. You divide by minus 4. But the moment you divide by a negative sign, whenever you're doing inequality, the moment you divide by a negative sign, the inequality sign changes. So this becomes y is greater than, because I have divided by a negative number, the inequality sign will change, which gives you y is greater than 3. Then the next one, they say, the perfect square y that satisfies the inequality is 1, but we know this one is the same as y is greater than 3, and y is less than or equal to 9. Find the possible values of y. We want to find the perfect square that are greater than 3, but we must end at what? At 9. What is a perfect square? A perfect square is a number that we can find its square root, and the square root of that number, it's a whole number. In this case, it's 4. 5 is not a perfect square. 6 it's not. 7 it's not. 8 it's not. And 9 it's also a perfect square, because if square root of 4 it's 2 and the square root of 9 is 3. So these are the 2 perfect squares that are within that range. Thank you for watching and enjoy your day. I will continue with question 5 until I finish the paper. Thank you.